Hi students, welcome to this new video on tutorial 9 where together we will solve question 5. You are given a matrix A as follows and A has 1 and 6 as eigenvalue with eigenspace E1 and E6. You are asked to check if A is invertible. So let's try to answer the first question. Is A invertible? So to answer this question, right, we know that A is invertible if determinant of A is not 0, right? And in this case, we can see that determinant of A is a product of the eigenvalue, which is 6. Therefore, A is not invertible because determinant is not 0, right? So let's have a look on the second question. The second question, right? In this case, you are asked if A is diagonalizable, right? So how do we answer such a question? Now you can see here that for the eigenvalue 1, we have two eigenvectors. So it means that we can clearly see that eigenvalue equals to 1 has a multiplicity 2, right? So to answer this question, you can also see that A is a 3 times 3 matrix, right? And we have three different eigenvectors, and we have three distinct eigenvectors, right? So A is diagonalizable, right? So let's have a look at the third question. The third question says that how many different such matrix P, so how many different matrix P and D, right, can we find to satisfy P minus 1 AP equals to D? How many? So we clearly know that we can find um, three matrices of D, right? So we can have D equal to 0, 0, 0, 1, 0, 0, 0, 6, and then we can have 1, 0, 0, 0, 6, 0, 0, 0, 1, and then we can also have 6, 0, 0, 0, 1, 0, 0, 1, right? So we can have three combination of value of an of D, right? So we can have that, and from this from this combination of D, we can um, we can have we can have infinitely we can have infinitely many, right, different infinitely many different P matrices, right? Because for instance, you can replace any eigenvector by a non-zero multiple of itself and use those to form P, right? So we can have infinitely many different matrices of P. Because remember that most often, for instance, you see if you check how this eigenvector here is is written here, you can see that it is alpha, it is alpha minus 1 to 0. So you see we can have infinitely many non-zero vector of this form depending on the scalar alpha, right? So that is why we have infinitely many P matrix. Now, the fourth question is for us to solve the differential equation. So we have to solve this equation, right? 3x1 plus x2 plus 2x3. We have 2x1 plus 2x2 plus 2x3. We have a 2x1 plus x2 plus 3x3. Right. So we have to solve such equation. Can you remember how we often solve such equation? Okay, let's have a close look. So we can rewrite this as x equals to ax, right? Okay, so this is the first equation. This is what we assume, and then we suppose that a is diagonalizable such that this is justified because it's equation 2. If we apply a change of variable by letting x equals to p y, therefore we have that x prime equals to p y prime, right? Which is equals to p, right? Which is equals to a p y, right? Do you agree? Yes, because x dot is ax, and we say that x is py. So this is obtained. Now, if we multiply both sides by p minus 1, we have minus 1 p dot equals to p minus 1 apy, which will lead to p dot equals to dy. Now, having it, we can see that this is the first order differential equation. So it means that having therefore my system given as this, I realize that x dot will be equal to, right, 3, 2, 2, 1, 2, 1, 2, 2, 3, right, times x1, x2, x3. And I can see that this is matrix A that I already know. I have its eigenvalue and I have the corresponding eigenvectors, right? So I can have the invertible matrix P and the diagonal matrix D, right? So once I therefore have this, I can then use this equation 4, right? Using equation 4, I have that x dot equals to D. Remember that I already have the eigenvalue, so my matrix D will be 1, 0, 0, 0, 0, 0, 0, 6. So D will be 1, 0, 0, 0, 1, 0, 0, 0, 6, right? And times y, y1, y2, y3. Okay, so once I have this, I can therefore have that y1 dot, y2 dot, y3 prime equals to y1 equals to y2 equals to 6 y3. And I can do the integration easily to have that y1 equals to alpha t equals to alpha et, y2 equals to beta exponential t, and y3 equals to gamma exponential 6t, right? Now, once I have this, right, you can remember that at the very beginning we let that x equals to py. So, and also my matrix P is already given, right? So I have minus 1, 2, 0, and I have minus 1, 0, 1, and I have 1, 1, 1, right? Times y. I have alpha et, and I have beta et, and I have gamma e6t. Okay, so therefore I can find my my solutions x2t and x3t given as, right? I can find them clearly here. So this will give me alpha plus beta plus gamma e6t, and I will have 2 alpha et plus gamma e6t, and I will have beta et plus gamma e6t. Yeah, so I have obtained this solution. Now, in question E, we say that find a particular solution. Find a particular solution, right? For x1 0 equals to 2, x2 0 equals to 1, and x3 0 equals to minus 10. So if we do it, stop it indirectly from here, right? We have that x1, 0 is minus alpha plus beta, right, plus gamma equals to 2. We do x2, 0 equals to 2 alpha plus gamma equals to 1. If we do x3, 0, right, equals to beta plus gamma equals to minus 10. Now I can therefore use directly this system of equation. And if you do the normal manipulation, that is, if from this equation, right, from this equation, I will have that um, gamma, I will have that gamma equals to minus 10 minus beta. And I sub in this gamma into the first equation here, right? If I do that, I can, if I do that, I will easily obtain that beta equals to minus 7, right? So if I sub this gamma into the first equation here and into the second equation here, and I solve both equations, I will have beta equals to 7, I will have gamma equals to minus 3, and I will have alpha equals to 2. So beta is minus 7, gamma is minus 3, and alpha is minus 2. Okay, now we also have this question that you need to solve this new system, right? If instead you have 3x1 plus x2 plus 2x3 plus 5, and you have x prime time derivative to x1 plus 2x2 plus 2x3, and you have x3 time derivative to x1 plus x2 plus 3x3. So we can put here 0, we can put here plus 0, 0, so that so that we so that we can be able to write this in this form: 3, 2, 2, 1, 2, 1, 2, 2, 3, right? And x1, x2, x3 plus 5, 0, 0. Okay, plus 5, 0, 0. Okay, so we can write it this way. Then we can then use the same procedure we used before to also solve this equation. So here we have that x prime time derivative equal to ax plus, let's call this a vector b, right? We know that b is 500. So what we will have, will have that this equation, right? When we want to find the value of we have that lambda y time derivative equals to dy plus minus p times b, right? We already know the inverse of p. It is given, right? We have is 1 over 5 times minus 1 minus 2 2 2 minus 1 1 minus 1 3 2, right? And then b is b is 500. So if you do minus 1b, that is, if you multiply this times b, right? Minus 1 minus 2 2 2 minus 1 1 minus 1 3 2, right? You will obtain 1 over 5. You will obtain minus 1 minus 2 2. Therefore, our system will be 1 0 0 0 1 0 0 0 6, right? And y1, y2, y3 plus minus 1 minus 2 2. Okay, so therefore we will have that minus 1 dot equals to y1 minus 1 minus 2 times derivative equals to y2 minus 2, and minus 3 times derivative equals to 6y3 plus 2. Now these are simple differential equations, first order differential equations. We can solve this easily by first finding the homogeneous solution and then finding the particular solution and then sum them together. And if you do that, you will have that y1 will be equal to alpha et plus 1, and y2 beta et plus 2, and y3 equal to gamma e6t minus 1 over 3. Now, if you have this, then we can finally have x, right? We know that x equals to py. P is none, is given, is minus 1, 2, 0, minus 1, 0, 1, 1, 1, 1, right? And then is yeah, so and then having this, I can then replace y is alpha et plus 1 and beta et plus 2 and gamma 60 minus 1 over 3. Okay, so once I have this, then I then do the multiplication of both of them. Then I will finally have my solutions as as um, as follow. So I will have minus 10 over 3 plus alpha is 60, right? Minus alpha plus beta um, et. Then I will have 5 over 3 plus 2 alpha et plus gamma E60. Then I will have 5 over 3 plus beta et plus gamma E60. So this is exactly what we have as a solution. We really hope that you enjoyed this video, and please feel free to email me to ask some further questions.